Hi, my name's Robin Moffat and I'm a developer advocate at Confluent. Today I want to talk about handling primary keys in the JDBC Sink connector. So Kafka Connect is a great way for getting data from systems upstream into Kafka and from Kafka downstream to other places like databases. And one of the most popular connectors is the Kafka Connect JDBC connector. So using the Sink connector element of it, we can take data from a Kafka topic and push it down to a database. You can use it with many different databases, those which support JDBC drivers. So you've got things like SQL Server and Oracle and Postgres and MySQL and so on. One of the things that sometimes trips people up is how to handle primary keys. So within Kafka messages, you have a key value pair. And then in databases, you have a primary key on a table as well. And the relationship between these two different keys, and sometimes they're the same and sometimes they actually mean different things, can be a bit of a confusing one. So today I want to walk through several different scenarios of different structures of data within your Kafka messages and how to configure the connector so that it does what you want it to. Let's start off with the most basic example in which we don't even send across a primary key to the database. So I'm going to use KSQLDB in my examples. I'm simply using it as a way of populating data into a Kafka topic and as a way of interacting with Kafka Connect. Now you don't have to use KSQLDB for any of this. There's a couple of bits where I'll suggest it's kind of useful for doing bits of stream processing where we need to, but what I'm showing you here is just generically applicable to the Kafka Connect JDBC Sink connector. How you populate your topics, how you interact with Kafka Connect is entirely up to you. So let's bring ourselves up a KSQL command prompt. And to start off with, we're going to create ourselves a Kafka topic and we're just going to insert a row of data into it. So KSQLDB lets us do this. It lets us say, create a stream, give it a name, and then here's the schema for the stream. We say which topic do we want to write the data to, and then here's how we're going to serialize the value part of the message, and we just got one partition in that particular topic. So we go and create that stream, and now we can put some data into it. So KSQLDB can work with existing Kafka topics, but as we've seen here, we can also create topics, and we can produce data into those topics. Since it's KSQLDB, it's like SQL-y, database-y, we're going to use insert into to actually push that data into the topic. So we say insert into foo, we name the columns that we want to send the data into and the corresponding values to use. So that's now produced a message to a Kafka topic. If I say show topics, we can see we've got a topic here called foo1, which is the one that we just created and populated. And I can say print foo1 from beginning. Limit 1, just show me the first message. And what this will do is it will act as a consumer against that particular topic. So we're using KSQLDB to declare a stream which has got a schema underpinned by a topic. And we could do a select from that stream if we wanted to, but that's not the point here. We've created the stream which has created the topic, we've populated the topic, and now we can consume from the topic using print. And print simply goes to the topic, takes its best guess at the serialization to deserialize it, and it dumps it out to the screen like this. And we can see on this topic, we don't have any key because we didn't define a key when we created the stream up here. And then we can see the value is made up of two fields, one called col1, one called col2, both with a 0 value. We can see here the value format is avro, so print takes like a best guess at the serialization format. Sometimes it does slightly funny things, we'll see that later on, but here it's got it absolutely right, it reckons it's avro, and it is. So now let's push this data down to a database. Here's my connector for Kafka Connect. We're going to say create a sink connector, so let's clear the screen. Create sink connector, we're using the JDBC Sink connector class. Here's our connection. I'm using Postgres for all of these examples just because that's what I've got to hand, but this works exactly the same with MySQL, with Oracle, with DB2, with SQL Server, with all of the other different ones. So we've got a Postgres connection here. We're going to pull in data from the topic foo01, and now this is where we get to the important stuff. How have we serialized the data on that topic? And this is, again, one of those things that really catches people out working with Kafka Connect in general, but particularly with the JDBC connector. When you're reading data from a topic, you have to know how it was serialized. You can't just like pick a random setting and hope that it works. So we have to find out how it was serialized. And since we wrote the data, we know how it was serialized. We know that the value was serialized using the Avro converter. So we specify that there. We say auto creates true. We'd like to go and create that target table in the database. So we've created the connector. And what we can do is we can say describe connector foo1, and it says, okay, it's running. And what we can do then is we can go over to Postgres. So let's do that, and let's bring up Postgres prompt. Postgres is somewhere over here. There we go on my clipboard. And we can do this. We can say list out the objects within the database. We've got one called foo1. We can say describe that. In Postgres, the object names are case sensitive, so we put it in quotation marks. And we can see here, it's got column 1, column 2, they're both an integer, and there's no key defined. If we say select star from foo1, it says there's the data in that table, so 0 and 0. So that's the data that we sent across from the topic into the database with no key defined. So that's the most simple example, taking data from a topic, pushing it to a table, no key involved. But keys are really useful. Keys serve multiple purposes. Keys have got a logical purpose with the data needing to enforce uniqueness amongst it. We set a primary key within the table in a database saying this column or this combination of columns can only have one logical value. But we also want to use keys as a means of identifying a particular row within that data. So if we want to take some information and push it to a table and say, if it exists already, update that particular instance of the entity. Or we may want to say, if we find it, then go and delete it. So we need to have a way of identifying those rows uniquely within a table, and that's the purpose of a primary key. So we want to be able to push that primary key information from Kafka Connect, from that Kafka topic, down to the database when we create the table and when we're working with the table itself. So let's now see an example where we bring in keys. What I'm going to do here is we're going to stick with just the payload in the value part of the Kafka message. So you've got to wrap your head around this. Kafka messages have got keys and values, and then the tables that we're writing to, it's a single entity, but within that you've got multiple columns, and one or more of those columns could be marked as the primary key. So get your head wrapped around that, and to start with we're going to say we're going to create a Kafka message with no key, but a value which has got multiple different fields, and we're going to use one of those fields as the logical key, as the primary key when we push it down to the database. So that looks like this. We're going to create ourselves another stream. Again, we're going to do it in KSQLDB. Again, it doesn't have to be in this. This is just a useful way of creating this test data. So we've got a stream called foo2. Again, 2 columns exactly as before. Same serialization, we're using Avro for the value format. And now we're going to insert some data into this stream, therefore into the Kafka topic. So we're going to insert those 3 values, and we can say print foo02 from beginning, limit 3, just show me the first 3. Again, the key is null. The value we can see there, so col 1 is 0, 0, 1, col 2, 0, 42, 94. So you've got those 3 different records, each with 2 columns. So now let's push that data down into Postgres. It's going to go and create a new table. With the JDBC Sink connector, the table name in the database is inherited from the topic name. You can change that using something called single message transforms. So you can manipulate the name and drop a suffix or a prefix from the topic when we push it down to the target database, or do a bunch of other manipulations to it if you want to. But by default, it takes the name of the topic. So we're going to create our sink connector here. The topic is now foo2. The serialization is as before, it's Avro data. We're going to create the table at the target, and now we're going to say I would like to use the record value to get the particular primary key fields. So we're going to get the primary key fields from the record value, and which fields are we going to use? We're going to use col 1. So the pk mode and pk fields is where you have to do all of the different configuration, and getting the permutations correct here is the kind of like the real heart of the issue. So we're saying within our Kafka message, which is what's kind of called a record here, so our Kafka record, our Kafka message, it's the same thing. We want to use a field within the value part of that message. We want to use one or more fields within the value as the primary key on the target table in the database. which fields do we want to use from the value within the record. We want to use a field called col1. And we could specify multiple fields here if we wanted to from within the value, but I'm just selecting one of them. So we go and create that, and it's created the connector. And if we say, let's go and have a look at the status of that connector, it says it's running. So let's go down to Postgres and let's see a list of our objects. We say, oh, well, but there's not our table now. We were expecting a table called foo02, but there isn't. Why isn't there? Let's go and check the connector again. It says, okay, it's definitely running. Let's go and check Postgres again. There's definitely no table. So what's going on here? Well, if we leave it long enough and we keep checking the status of the connector, we're going to see what's happened. But I'm kind of impatient, so let's go and have a look directly at the log of Kafka Connect. So when something goes wrong with Kafka Connect, you can look at the status of the connector and the task, but you can also go down to the log, because sometimes things don't fail straight away. So I'm going to say docker logs Kafka Connect, because that's the name of the container running Kafka Connect. And if we page up here, we can see some bad things going on. We can see there's a connect exception. We can see we're getting errors, looks like from Postgres. Batch entry here, insert into foo02, so it's trying to do something. It was aborted. Error, duplicate key value violates the unique constraint. So here's the problem. We've created a unique constraint, a primary key, on col1, but within col1, we've got duplicate values. So the primary key is behaving exactly as it should. So let's head back over to ksqldb, because if we check the state of the connector here, and remember, ksqldb is just invoking the Kafka Connect REST API under the covers to look at the status. It says, okay, actually that connector's not so healthy. So the connector will sit and it will retry, which is why the status was there as running and like everything's fine, but in the log underneath you could see these retry attempts and each one erroring out, which means that eventually it fails and the connector is in this status of it having failed. So you can see here we've got this batch entry. So this is the error that we saw in the Kafka Connect worker log. Now if I say, let's have a look at the data within that topic. So we had a print command here. We can see, not from that one, but from this one, limit 3. We can see here col1, which we're setting as our primary key. We've got two values for two records, both of which have got the same primary key value. So you can't insert two records with the same primary key. That's the whole point of a primary key. It prohibits that kind of duplication. It's a violation of that constraint. So what's happening here is the Kafka Connect Sink connector is trying to insert those three records. And what we actually want it to do is to say, in this case, these are three valid records. Because in this case, we're saying, well, logically, that second message here is just an update of the first. So whatever data we're representing here, here's the first event relating to that data with this particular key. Here's a second event relating to data for the same key, just with a different value. So something got updated. So it may be this is actually a logical, a completely correct violation, in which case you would want the primary key to do its job and you wouldn't want to overwrite it. But here we're saying, actually, no, this is a logical update. So what we want to do is we want to configure the connector to say, if you get a message with a key which already exists, then go and update it. So insert it if it doesn't, update it if it does. And this is called an UPSERT. So let's go and create our connector, and it's going to go and look like this. We can say create a new version of the connector. So we'll leave that existing connector as it is, because it's failed, so it's not going to do anything else. And we're going to say create a new version of the connector. And what we're going to change here is we're going to set the insert mode to UPSERT. So by default, the insert mode is insert, which means it will insert the data, and if it hits a violation on the key, it will fail, like we saw. But here, and this is like an application design decision. The data that's flowing through, what do we want to do with records that have got the same key? Do we want to reject them and like fail if we get any duplicates because we're not expecting them, or do we want to treat them as updates of an existing key? So we're saying we want to treat them as updates. So now when we go and create this connector and go and check in the Postgres, we can see we've now got our table created. So we had three source records in our Kafka topic. When we go and check that table in Postgres, let's describe the table first and look at its structure. We can see here, let's make a bit more space. We can see here we've got the two fields here. Col1 is marked as not null, because it's the primary key. And we know it's the primary key because it says so down here. So it's a primary key, therefore it has to be not null. And if we select the data in that table, remember we've got 3 records in that source Kafka topic. So select star from foo02. Just have a little think, as I'm kind of like talking here, how many records are we expecting to see in that table? We've got 3 in the source Kafka topic. How many in the target table? We've got 2, because one of those Kafka messages was a logical update for an existing key. So if we have a look at the topic itself that the data is coming from, here are 3 messages. Col1 with a value of 0 has got 2 messages, which means that it's going to update it in the target database, and that's what we see here. So col1 value of 0, it ends up as 42. It started as 0, then it became 42. Col1 here with a value of 1 has got a value of 94, and that doesn't change. So we can push additional records into that source topic. So if we go and do this, we're going to do another insert into in KSQL DB, which writes another message onto the Kafka topic. And we go and query that table in Postgres again. Now we can see we've got a new message added into that table. So as we're writing data into the Kafka topic, it's getting pushed down to Postgres. And if the row doesn't exist, it inserts it. If that row already exists with the same key, and we've told it to use col1 as the key, then it will update it instead. So what we've got here in the previous example was a value struct, which has got 2 fields within it. One of those fields we marked as the primary key, the other one wasn't. Now we're going to create a stream which is going to have 4 columns within it, and it's going to look like this. And within that, we're going to mark multiple fields as part of the primary key. So that looks like this. Column 1 and column 2 and column 3 and column 4. So we've got some integers, some varchars in there. Again, we're serializing it as avro. And now we're going to push this into here. And we're going to say we want to use these first 3 columns as a composite key. So we can create composite keys using the JDBC Sink connector. So our composite key is going to be made up of these 3 fields here. So 1, 2, 3, ABC, and then these ones here. So if you look at this and think about it, we can see we've got 1 key there. And then this key here, this composite key, gets repeated, and it's got 2 different values associated with it. But at the moment, this is just a Kafka topic. Let's pull up Kafka Cat just to kind of show you what's actually going on with this under the covers. If you really don't believe me that you don't have to be using KSQL DB, we can use Kafka Cat. It's not nearly as friendly to invoke as print topic that we do in KSQL DB, but it's doing the same thing. So we're going to have a look at the data, and it says here, let's make that window a bit bigger. We can see we've got a key, which is null for each of those 3 records. And then we've got col1, col2, 3, and 4. So we're just writing data to a Kafka topic within our Kafka brokers, and we're pushing that data, we're producing that data using KSQL DB. Now let's take that data that we saw in that Kafka topic and go and push it down to Postgres. This time we're going to specify multiple fields from the value part of the message. Remember, we've still got null keys in our Kafka messages. We're still just looking at how to use parts of the value for the primary key. So because it's from the record itself and we're taking fields from the value part of it, we say pk.mode is record value. Which fields from the value of the record do we want to use for the primary key? We want to use these 3 fields here. And we're going to use UPSERT again. So now we go and create that connector. And if we go down to Postgres and list out our tables, we can see we've got a table here called foo3, and if we describe that table, we can see here it's got a primary key made up of those 3 fields, and because it's part of the primary key, they're not null. And we can query the data, select star from foo3, and you can see the data is there. So you've got our column 1, 2, 3 like that, which has got that value. If we remind ourselves what the data looks like in that Kafka topic, so our Kafka topic was foo03. You can see here you've got column 1, 2, and 3 have got this same composite key here, which is why we end up with this value here, this III in the column 4, once that data has been pushed down to the database and has done that UPSERT against it. So far, we've looked at how to get data from our Kafka topic down to a database using either no primary key at all, or by identifying fields from within the value part of the Kafka message as forming the primary key. You can take 1 field or multiple fields for a composite key, but this is all from the value part of the Kafka message. But Kafka messages are key value pairs, so we can actually specify the key as part of the Kafka message. And this logically makes sense as well, because the key is there for a good reason. We can use it to identify the data that we're putting into the payload. So sometimes you'll use the key in the Kafka message because you need to make sure that those messages for a particular key end up on the same partition, because the key is used by default as part of the partition assignment. So you may be handling orders and you want to make sure that all orders or all messages for a particular order end up on the same partition. So you use the order ID as part of the key and you put the order ID into the key of the Kafka message. But even if you're not so fussed about which partition your data ends up in, if you've got a logical key to your data, which if you're wanting to create a primary key in the target table, it kind of implies that you do, it makes sense to put that key into the key part of your Kafka message. Now, we need to talk about primitives and complex keys. A primitive key is where we just write a string or an int or a long into the key of the Kafka message. And you can do that, but if you do that, you can only have that particular value as your primary key in the target table. You specify a name for the column that you want to populate with that key, that primitive key from your Kafka message. You can also use a complex key in your Kafka key. So you can say, I'm going to serialize it using Avro, and it's going to have a nested structure to it. So we're going to have an ID and a country and whatever other components make up your particular key within that Kafka record. So this is kind of fiddly, and I'm saying key an awful lot of times. So let's actually work through some examples and see how it looks. So I'm going to create myself a stream within KSQLDB. Again, I'm just using KSQLDB because it's a useful, easy way to produce data into a Kafka topic. We're saying we're going to create a structure within our stream. So we're saying col1 is actually part of the key. And then we're saying we've got col2 and col3 are an integer and a varchar. KSQLDB will write this down to a topic and it will serialize it using Avro for the value, and then the key itself it will write using the Kafka format, which means it's going to write it as a primitive. So we're going to end up with a primitive key as a string key for anything that we write into col1, and then col2 and 3 will be serialized using Avro as part of the value part of the message. So we go and do that, and then we're going to insert some rows into it. So we're going to say insert into our particular stream, into our particular topic, these different values. And so we do that, and then we can say, let's have a look at that particular topic. Now I've used print so far in these different examples, and it's worked perfectly. It takes a guess at the data, how the data is being serialized, and it tells us and it deserializes it. Now, data within Kafka messages, it's just bytes. So usually as a developer, you would have to know, well, how's it been serialized? Oh, it's been serialized using Avro. If I want to read it from the command line, I'll use the Avro console consumer. Or I'll use Kafka Cat and I'll configure it and I'll tell it this data is in Avro. Or I'll write an application. And in my application, I'll say, well, I need to use the Avro deserializer or the protobuf deserializer. And you as a developer have to know. KSQLDB is pretty cool. It says, well, I will read those messages and I'll take a fair old guess at how they've been serialized. It doesn't always get it 100% right, because if you think about it, bytes are just bytes. So kind of like trying to guess in what way it's been serialized isn't always actually that straightforward to do. So we can see that here. If I say print this particular topic from the beginning, limit 3, it says, okay, here is the data. The value part, it gets spot on. It says the value, well, I reckon it's Avro. The key, it says, well, it could be a Kafka string, which is what it is, but also it could be a data that's been aggregated and has got a window function behind it, so like a tumbling window or a hopping window, which has nothing to do with what we're doing here. But it's taking its best guess. It's saying, well, okay, looking at the first few bytes of that particular message, maybe it's a hopping window, so I'm going to display it as that. So that's what it does here, which is kind of why it looks a bit funky. It's kind of saying, well, if it were a hopping window, this is what value it would have. The actual value that it's got, we can find out using Kafka Cat. So here's Kafka Cat to go and look at it. I'm going to do this and paste it in. So Kafka Cat can say, we're going to use the schema registry here, and this is where I'm saying as a developer, you have to tell it how to deserialize it. So we're saying the value itself is in Avro, the key is just a string, so it'll do that by default. And then we're saying format the output in this particular way. And it says, okay, here is your data. It says offset 0, you've got a key with that value, which is just a string, and a key here and a key here. and then we've got our value. So unlike before, where we were writing null keys and all of our data went into the value part of the message, the value part of the record, now we're saying we've got some value data and we've also got a key. So now let's use that key and use it as the primary key in the table that we're going to populate. So now we need to understand a little bit more about pk.mode and pk.fields. This is what it looks like. So let's close that window there. And we're going to say, right, take the data from this topic as before. The value converter is avro as before, but the key converter is string. Now, if it were an int or another type of number format, we would use a different converter here. I think there's a long converter and an int converter. I can't exactly remember what they are, but they are in the documentation. But because it's a string, we use the string converter. And getting the converters right is always important. I was going to say it's always key, but we've said key too many times already. Key converter is a string converter, so it doesn't have any other fields configuration associated with it. You don't need like key converter.schema registry or key converter.schemas or anything like that. If it's a string, it's just a string. So we just say key converter is string. We're going to auto create the table. And now we say, I would like to use for the primary key in the table we're creating a value from the record key. Previously, we said we're going to use the record value when we talked about fields from the value. Now we're saying I would like to use a field from the key of the record. But because we're using a primitive key, we're using a string key, or if we're using an int or a long or something, we've only got a single field there. And it's a primitive. It doesn't have a wrapper or an envelope around it. It's just the value itself. Which means pk.fields in this context means what name field in the target table do you want to create and put the key into. Other times when we're working with the record value, we've had a field name that we identify, use this field as the primary key. So it uses that field and it creates it in the target table. But now we're saying use this key in the Kafka message, and the key doesn't have a name, it's a primitive, it doesn't have a wrapper or an envelope, it's just a primitive value. So now pk.fields is what's the name of the column of the field in the target database that you would like to create in which you're going to store that key value. So we're going to call it foobar, just to make it absolutely clear, it's just a random name. And we're going to use UPSERTs as before. So we go and create that, and we head over to Postgres and we say have a look at these tables, and it says you've got one called foo4. So let's have a look at that, foo4. And it says, okay, you've got col2, you've got col3, which were the values, the field names from our value part of the payload. And now we've got foobar, which comes across as a new field the connector is created based on the pk.fields name that we specified there. That's specified as the primary key. And if we have a look at the data in that table, oops, not that one, that one there. You can see you've got the data. So for the particular key A here, it's got a value of 5 and ZZZ, and for B, it's got that particular value. If we remind ourselves about the data itself, we can say print this particular topics. This is the source topic here. Oh yeah, the key doesn't work so well on this, does it? So let's bring Kafka Cat instead. Got that on our bash history. So foo4 here, and we can see for my key val A, we've got two different records. So this is like we were talking about before, where you do an insert if it exists, an update, an insert if it doesn't exist, an update if it does. So my key val A has got two different records. To start off with, it's got a value of 2 and ABC, and then you get my val B, and then you got val A with 5 and Z, which is what we see here. So that's pulling through the data from a Kafka topic. It's using the primitive key and bringing that into the target table. So when we've got pk.mode is record key, it's saying, well, assuming the key is a primitive, just use pk.fields as the name to put that primitive into in the target table. So we've seen you can update the messages on the topic. We saw this one here for the value A key. It updated those particular rows there. We've seen inserts, we've seen updates. What about deletes? Now in Kafka you have the concept of tombstone messages. These are what are used as representing a logical deletion of a particular key. So a tombstone message is where you have a key and then a null value. So you can only use tombstone messages to delete records from a target table if you're using the key of the Kafka message to represent the key on that target table. It's no use if you don't have a key in your Kafka message, because if you don't have a key in your Kafka message and you have a null in the value, which is by definition a tombstone message, then how do you identify that target record to delete? So we have to have a key in our Kafka message, and then we set the value to null. So let me show you what happens here. We're going to insert a null into our Kafka topic. You can do it using KSQLDB. It's a little bit funky. There's a blog I wrote about it, but we can do it nice and easy using Kafka Cut. Obviously, if you're using the producer API, you just go and write a null using the producer API. So we're going to say for my key val A, insert a null, which is what this -z argument means, because we're using a colon as the key separator. So we're going to write it into that particular topic there. So we've inserted that. And to start off with, if we go down to Postgres, nothing happens. So we figure something must be going on here. So let's go and have a look at the particular connector. So what we're going to do is we're going to drop the first connector that we were using. So drop that particular connector. So that's removed the Kafka Connect connector that we were using. And now we're going to create a new version of it. So this new version of it is the same as before, except for we're saying delete enabled is true. So by default, delete enabled is false. Here we're saying set it to true. If you receive a tombstone for this defined primary key, then delete it from the target table. So again, we're using foo4, so again, it's going to apply to this foo4 table in Postgres. So we'll create the connector and head down to Postgres. And now when we select from that table, that row is gone. So that connector that we created, it started from the beginning of the topic, because we gave it a new name. So it read through all of the messages, it read the three insert updates, and then it hit the tombstone message, and it said, okay, it's a tombstone, so I'm going to delete it for that particular key. Let's have a look now at how you can use structured keys with the Kafka Connect Sink connector. We're going to write some data into a topic again, but this time we're not going to use KSQLDB, we're going to use the Avro console producer. So here we're going to spin it up. I'm going to run it from the schema registry because this whole environment is on Docker. It's all on GitHub, by the way. So if you want to take this away and try it, you just clone the repository and say docker compose up, and you get the whole environment. So we're going to come out to KSQLDB, and we're going to go into the schema registry container because this is where the Avro console producer script is. So we're going to run this, and what we're doing here is, let's make that a bit bigger so you can see what's going on. We've got Kafka Avro console producer. We're going to write it into a topic called foo06, and here we specify the schema for the key and the value, and then we're going to specify the actual data that we're going to insert. So the key schema, we've got k1, which is a string, k2, which is an int. So two fields within the key schema. And then within the field, the value fields, we've got col3, which is a string, and col4, which is also a string. We say we're going to send data using the command line producer. We're going to separate the key and the value using a plus symbol. If we had a plus in our data, we'd have to pick a different one. And this is what we're going to put in. So k1 is going to have these values, and then there's our separator, and here's the value part of it. So we're going to put that into our particular topic. The producer spins up and it runs and it pushes the data into the topic, and that's kind of served its purpose, so we can close that. And now if we head over to KSQLDB, we can have a look at that data. So now we can see the key format is Avro, and it's picked it up correctly this time. So it took a fair guess at it and it got it spot on. So the key looks like this here, and we've got the value. So we've got three different records, three different messages within this topic, and we're going to push this down into the table, and we're going to use both keys as the primary key in the target. So our connector looks like this, and we're going to say create our sink connector, and now this time what changes is our pk mode is record key as before. So just like with a primitive key, we're saying the primary key comes from the key of the Kafka message, the key of the Kafka record. That's what this means. So from the record, take the primary key from the key part of the message. But with a primitive key, which we had before, you had to give it a name because it was a single value, so you had to specify this is the name that we want to write it to into the target table, because it didn't have a field name within the Kafka key. It's just a primitive value. Whereas now we have a structured key. We have a key which has got fields, we've got K1, K2, and so we can specify either nothing here. If we specify empty pk fields, it's going to use all of the fields that are available, and each of those fields are going to form fields in the target table and all be made into the primary key. Or we can cherry pick different fields out of the key if we only wanted to use some of them. But here we want to use all of them. We're going to use the UPSERT again and enable delete. So that creates that. And now in Postgres, you can see we've got our table here, foo6, and if we have a describe that table, we can see we've got col 3 and 4, which is our value part of the message, and we've got K1 and K2. They've inherited their data types from the schema as specified, and we can see here K1 and K2 form the primary key. So that's exactly what we asked it to do. And if we say select star from foo06, it says it's not so happy with that, so we run it again, and now you can see you've got our full payload has come across. So there are our key fields, and here is our payload, our particular values that were specified in those different Kafka messages. What we can also do though is we can specify different key fields to use. So perhaps we don't want to use K1 and K2. Perhaps for the purposes of what we're doing, we just want to pick particular records and use the key to roll them up somewhat. So we can say, well, let's go and get rid of this particular connector. So we're going to say drop connector, so stop pushing any more records across. In Postgres, we're going to say drop table foo06. Okay, let's drop that table. And now we can create the connector again, but this time we can actually name a field to use from the key. So we've got the key converter is an avro, as it should be. We've got the record key we're using for the pk mode. The pk fields, here we're saying just use K2. So this 1, 2, 3 here, that's going to form the primary key. This K1, actually, as we'll see in a moment, is just going to get ignored. So we push that across, and now, because we dropped foo06, what gets created in its place is what that connector's gone and done. So we can see, have a look at that, and have a look at foo06. So here's K2, so that's the particular part of the key that we said to bring across. The primary key is that, and there's our payload columns, our non-key columns. And we can say do a select off that table. So we can see there's our key, there's our value, not that one there, not there, that's our value as before. But what about if you want K1, but you just don't want it as part of the primary key? So here we've got a Kafka message, it's key value. We've got two fields in the value, we've got two fields in the key, but we're saying of those two fields in the key, we only want to use one of them as the primary key. The other field we want to treat as part of the value, as a non-key column. To do that, we're actually going to have to manipulate the data somewhat. You could probably write a single message transform if you wanted to, and go and write a bit of code which would say, well, move these particular fields from the key into the value. But here we're going to use ksqldb to do this. So within ksqldb, we're going to register that topic that we populated previously using the console producer, register it within ksqldb. The value and the key are both avro, so we can just say format equals avro, that applies to both of them. So we create that, and we can say, let's have a look at the schema on that. It says you've got a row key here, which is made up of the K1 and K2. Whether you have it as a struct or individual fields, it's the same net effect. This is just how ksqldb interprets it, but the fact it's called a struct doesn't actually mean it's kind of nested within something else. That's just the two key elements there. So we're going to take this structure that we've got in the existing topic, where we've got the key made up of the K1 and K2, and we're going to create a new stream, which is backed by a Kafka topic, and we're going to populate it from this existing stream. So all existing data and any new messages that then arrive. So to make sure that it processes all of the existing messages, we're going to set the auto offset reset back to the earliest. Then we go and create our new stream, and our new stream looks like this. So create a new stream as the results of selecting these values. We're going to select the existing K2 and say partition by K2, so that sets the key on the target stream. And then we say K1, we're going to pull into the value part of the message. That's what this function as value does. And we select the existing col 3 and 4. We go and create that stream, and we can say describe that stream there and just check the structure on it, we can see K2 is now our key. K1, col 3 and 4 are part of the value, which is what we wanted. So now we can go and create ourselves a new connector. So we're going to say create sink connector, and that looks like this. It's the same configuration as before, except we've got a different topic. And then pk fields, we're leaving as blank. We want to use all of the fields within the key on this particular topic, and the key now is just K2. So we go and create that connector. And if we head into the database, what we should see is the table existing, but it turns out it's not. The reason for that, if we're going to have a look at this, the list the connector, we can see within the connector itself, it's thrown an error saying we need exactly one pk column defined since the key schema for records is primitive type. So what's happened is because we've got a single field, it's been pushed down as a primitive. So now we actually do need to define that name. So we're going to say create the connector, and it's going to look like this. And this one here, so pk fields is going to be K2. So create the connector. Let's describe it. The connector here. That says it's running. So now if we go to the database, now we get to see our table. So we can take that and we can say list status of that, or the structure of it. So there's K1, 3, col 3 and 4 as parts of the non-key columns, which is what we wanted. K2 itself is the field that we wanted as the primary key, and it's been set as that. We can see it's been set as that there as well. So hopefully that's been useful for you. Handling primary keys is really important to get right when you're working with a sink connector, because keys have got such important semantics when we're working with data. pk.mode tells us where we're going to get the key from. If it's from a value part of the Kafka message, we say record value, and then we identify one or more fields from the value part of the message. If it's coming from the key part of the message, we say pk.mode is record key. If it's a primitive key, pk fields is the name that we want to create as a column in the target database to hold that primitive value and mark as the primary key. If it's a structured key, then pk fields is either blank and use all of the fields within that structured key, or it's one or more named fields that you want to use for that primary key in the target. Getting your serialization right is absolutely vital, as always. Remember, you can't just use straight like CSV or JSON data with the JDBC Sink connector. You have to have a structure to your data. You have to be using Avro or Protobuf or JSON schema, serialized using the serializers from the Confluent schema registry. So hopefully that's been useful. It's really interesting to dig into it at this kind of detail. Leave a comment in the video. Tell me if this was useful. Tell me if there are other ideas that you would like to see me do a deep dive into. As always, please do subscribe to my channel. It's great to see more subscribers. Leave a thumbs up, leave a comment, tell me if it was useful, and stay tuned for lots more videos all about Kafka Connect, KSQL DB, and Confluent.